What's up everyone, Dylan here, and welcome to Advent of Code 2025, Day 3 in Python. Just a reminder that if you want to take a look at today's code, then you can find a GitHub link down in the description, and also if you're interested in seeing how to automatically download your puzzle input with Python rather than copy and pasting, you can check out the video on my channel. Without further ado, let's get into it. So for today's problem, we have an elevator that has no power that we need to ride. And the elevator is powered by batteries, and we can see that there will be a couple of different power banks with each number in the power bank representing a battery. So it looks like our task is to find the maximum voltage that each power bank can provide, and that voltage is found by the largest number that we can make if we choose two digits and read them left to right. So let's go ahead and get into the code. So first of all, let's just go ahead and take a look at our data, our input data on the right here, and we can just see that each one line represents a power bank. So actually today, there's no need for a parse function. Let's just go ahead and start. So we'll go ahead and take total, which is 0, and then for, let's say, power bank in data, we will start by finding the largest digit for tens. And we'll just store the index of that digit in left, and by default that'll be 0, the first index in the bank. So say for I in range, and like I said, we're going to check all the numbers except for the very last one, because if we assigned the tens digit to the last digit, there'll be nothing left for the ones digit. And we'll just say if bank of I is greater than bank of largest left, then we'll go ahead and update left with I. And then we will find the largest digit after left for the ones. And we can go ahead and say that our largest index, or the index for the largest digit, will default be left plus 1, which is guaranteed to be in range. And then we'll say for I in range left plus 1 all the way up for the length of the bank. If this time bank I is greater than bank right, then we'll say right is equal to I. So I think that should be pretty good. So last, we will just convert to a number. So num will equal to int of bank left concatenated to bank right. Remember at this point, bank left, bank right are just strings. And total incremented by num, and finally we'll just return the total. So if we give this a run here, okay, 16946, and great, I get the gold star. So let's continue on to part 2. And part 2 says that we need more power. So instead of finding the largest 2-digit number, it seems that we should find the largest 12-digit number. Interesting. I think this problem is making sure that we don't brute force our solution. So let's go ahead and take a look. So what I want to do for this problem is, well, I could just hard code for 12 batteries, but I want to find a general solution to find the largest voltage that can be created given any number of combined batteries. So we'll say def get voltage, and this will take a bank, which should be a string, and a number of batteries, which should be an int, and it will also return an int. So the way I'd like to approach this is we will save all the indices that we want to use for the batteries in a list called batteries. And basically what I'm going to do is I'm going to write a list that grows until we have the correct number of batteries. Since each index represents one of the batteries in the bank, we can basically follow the pattern from up here by looking at the previous battery and then start searching from the one right after it. Now, in order to make that work, I think we're going to need a dummy battery at number 1 that we'll eventually ignore. So we'll say for battery number B in range, and because we already have something at index 0, we'll start at index 1 here and go up to the number of batteries plus 1 so that we make sure to include that 12th battery there. And we'll go ahead and append where we should start searching for the particular digit that we're on. So I'll say batteries append, and this will take the index of the last battery index that we saved, and we'll go to the left of it or the right of it one. So that's kind of like how here in right we took the last one that we saved, added 1, and that's where we start searching from. That's exactly what we are going to do here. Take the last one that we saved, add 1, and it's going to get added to the list and indicate that that's where we start searching from. Which is why I needed this dummy -1, because for the very first battery, it needs something to read, then we'll add 0 to that and get, or add 1 to that and get 0, which we can start searching for the first battery. Then we'll say for I in range, and this will be batteries B, meaning the particular digit number that we're searching for. And we're going to go for the length of the bank minus the number of batteries plus the battery number that we're on. And so what does this do? Well, the length, just like here, for the first battery, we only wanted to go to everything except the last index because we need room for all the other batteries to come after it. So here, if we're on the very first index, or the very first battery rather, we need room for 11 more batteries after. So what this will do is it will stop us from going too far along the bank. And this plus B offset from the battery number that we're checking for is going to kind of shrink that down each time, so it gets closer to the end. And then we'll just check if bank of I is greater than bank, and for here we'll take batteries B. Then batteries B is equal to I. So bank of batteries B is basically going to look, okay, we're at, say for example, the second battery index that we're searching for. Go find the index that we saved previously, or not previously, but that we have saved on this iteration of B. And if it's greater than what's already in there, then, or it's greater than the one that we're checking right now, then update it like here. So at the end of this loop, we'll have a total of number of batteries plus 1 values in this list. But remember, the first value is just a dummy value that we're going to ignore. So we're going to have num batteries, number of valid indices in this list. So how do we create a number from that? Well, let's just get a list of the on batteries. We'll pull them from the bank. And that will be bank I for I in batteries. But remember, we only want everything after the first one because of the dummy value. And then we can just return the int of the join string of all those batteries. So that should, in theory, give us the largest possible value for this particular bank. That is num batteries numbers long. And here in part 2, we'll just write total is equal to 0 for bank in data. Then we can say total plus equals get joltage of the bank. And here I will just go ahead and hard code in 12. And then finally, return total. So if we go ahead and run this code, we get a much longer number this time. and testing out my answer. All right, you can see we get the gold star. So real quick before we wrap up, I want to explain the solution one more time. So essentially what we're doing is we're building a list of battery indexes where each index represents the number in the bank that we should use. And as we go along, we populate that list. So when we start checking a battery, we add the index that we should start checking from. So everything to the right of the last number that we saved. And this, one more time here, is just going to make sure that we don't go too far so that there's room for the rest of the indices after we've found our largest value. So hopefully that makes sense. And if you have any questions, I can clarify them down in the comments. But anyways, that will be it for Advent of Code Day 3 here in 2025. Hope you enjoyed the video. Remember, you can see the code on GitHub, and I will see you again tomorrow.